It's good to see so many of you here this morning. I hope you're doing okay on your homework, and also that everything's going for you okay for you at home. I'm gonna stop sharing that so that we can. Well, you can see me. I can't really see you, but I can sort of see who all's here. Chloe, yeah. Do you need something?
Yes, I just want to ask if, yes, can you hear me?
Yes, I can.
I don't know if it's just me, but it sounds like it's a really bad echo. I don't know if it's just my end or it's everyone that's experienced the same because I'm struggling to hear and understand right now.
Okay. Is anybody else hearing an echo? Chloe,
I hear it just fine.
oh, okay, thanks, guys. Chloe, you might try on the blackboard on this session, going out and coming back in. Maybe that will help.
Yeah, I'll try that. I'll log out and log back in. Sorry, I was just
Well,
wanting to know if it was me or
I hope
not.
you're able to fix it. Yeah, because that's really annoying.
Yeah, thank you.
Sure, sure. So, I want to talk to you guys about a few things. I'm going to try to not say anything too important until Chloe gets back. But are you guys able to see the Learning Catalytics quiz? Did it pop up, a Learning Catalytics quiz on 3.1 through 3.3? Did anybody see it? Yes, Mia, you saw it. Okay. Saw it this morning. Okay. Okay, so we have that Learning Catalytics quiz. You need to look for that. It's over 3.1 through 3.3. And I can't remember when I made it due. Would someone mind looking at the due date on that for me? Does it tell you? Do you see the due date? Well, actually, I can look at it here.
I think it says Wednesday.
It says what?
I believe it's Wednesday.
Okay. All right. Yeah. Weirdly, it doesn't show me that. I would have to go to another place to see that. So you don't see a due date? Okay. While we're waiting for Chloe to get back on, I'm going to look at that really fast, okay? So I can tell you for sure what the due date is on it.
Miss Catherine, I've logged back on.
Is it better?
Yes, it is so much better. I think it was just my connection was really it was bad. So we're good. Thank you.
Sure. Okay, I'm seeing that this Learning Catalytics quiz is due on the 12th. And today is the 7th. So you have quite a bit more time. I would probably, it's not hard, it's mainly over definitions, and you can use, it's not a proctorial quiz or anything, you just do it through my math lab and take the quiz. It does count for a quiz grade. You'll notice it has a Q in front of it. And it's just a short quiz to kind of check your understanding of those first three sections of chapter 3. So there's that. That's a thing that you'll need to do before October 12th. Kendra, do you have a question?
Yes. That learning catalytics quiz. I did have a question about that. I wasn't able to find a dictionary when I tried to look for the vocabulary for it.
you need to do the home vocabularies in the homework for 3.1 through 3.3. You should not have to use a dictionary. You should take notes on the recordings, on the lectures. I've gone over all the definitions in the quiz and do the homework. So the idea, guys, is for you to do your 3.1 through 3.3 homework first and then take this quiz. So, but if you already started it, I don't know if it will give you another attempt or not. I'll have to look at that. But on all of the learning catalytics quizzes, you should, or on any quiz really, you should, I put them on there so that you can start them. But you want to make sure that you're prepared for them before you take them. You should never have to open a dictionary. Okay? You should be able to get everything you need from your notes over the lectures and from the homework that you've done. So since this is on 3.1 through 3.3, you should have completed that homework prior to trying this quiz, and then the quiz should seem really easy. Okay? So, but I'll look at that and see if another attempt can be allowed. I don't know. I'll look at that. Okay? All right, so, and then another thing I put on there, I don't know if you guys saw it, but I put a proctorio practice. For test 2. And I think I have this due like on the 13th or the 14th. You can do it as many times as you want to. It's a review for the test, but it's also a review of proctorio. So if you had any issues with proctorio for test 1, or if you didn't take test 1, then you really need to do this proctorio practice. Plus, it'll help you see if you're ready, if you have any issues with things that are going to be on test 2. Now, on this proctorio practice, I did not put any show work problems. So that means you're just going to have to show your work on paper. You don't need to send it to me. This is just for practice with proctorio and also to help you review for the test. And on this, though, there will be a few problems where I ask you to show work, just as I did on test 1, which means you need to practice showing your work. And so that's why on some of the homework assignments, I made a few of them. I just picked a few for you to show your work. I'm not going to check it. It's going to give you credit if you get it right and not give you credit if you get it wrong, the answer. I put those there purely so that you could click on show work and practice with the type tool. So I want you to try to get good at typing your work, or you may want to play around with that little pie button thing that looks like this on the show work. Looks like a little pie, you know, the Greek letter pi. And if you click on that, and then it opens up another thing, and you have to click on that, and then it opens a big tool thing so that will allow you to type fractions and different things. So my thought is I put those show work just so you could go in and practice and play around with all the things that are available. The work doesn't even have to match the problem that it's on. It's purely there for you to practice. But some of the problems I put show work on are the type of problems I would expect you to show work. If you ever want me to look at your work to see if it's correct or see if it's sufficient or see if you're showing enough work, just email me and say, hey, I showed work on this homework assignment on number such and such. Can you look at it and see what you think? And then I can go in and I can put feedback on that work. So, because remember, when you take the test, you may get an answer right, but if you don't show the work the way I ask you to, you're not going to get any credit. So the goal is not just to get an answer right, but to learn how to show your work correctly. And also start practicing, if you haven't already been doing it, practice numbering every problem that you do, writing down the given information, and showing the work. Because I'm going to want you to do that on this next test, just in case I need to see the work. Now, one thing you don't have to do for the next test is you don't have to send me your ID. I already have it if you sent it for the first test. So if you already did that, no worries. If you did not send me your ID, and I don't know, I'll have to look and see if there's anybody whose ID I didn't get. But if you got a grade for the first test, that means you sent me your ID. If you didn't take the first test, then you may or may not have sent me your ID. So some of you may still need to do that. And I think that's all about that. So make sure you do these two things here. On Monday, we're going to be reviewing for test 2. And I think I'm going to have you actually there's another Learning Catalytics review quiz. I think we're going to actually take that during the break. So we'll kind of work on it together. So make sure you're here on Monday to review, and we'll be kind of doing the Learning Catalytics quiz together for the review. All right? And then everybody will have it done and hopefully make a good grade on it. And those watching the recording, if you watch the recording for Monday, you could take the Learning Catalytics quiz while you're watching the recording, or watch the recording first and then take the quiz, something like that. I don't know if it'll let you have both things open at the same time. Probably not. So it will let you have this open, though, Blackboard Collaborate, while you're taking the quiz. So you will be able to do that. All right. Okay, so those are things coming up. And today we're going to start with questions on 3.4. If you have a question from section 3.4, please type it in the chat, or you can turn on your microphone and tell me. Okay, so Mia asked, if you took the first proctorio, do you get extra credit for the second one? I will probably give you another extra quiz grade of 100 if you take the second proctorio quiz. I haven't decided on that yet, Mia. Let me think about it, and I'll let you know next time. What I may do, since I give you unlimited attempts, is that if you're able to make 100 on it, or I'll count it as an extra quiz grade, or replace a low quiz grade with it, something like that. I'll count it in some way if you take it, though. How's that? So, and I'll decide later. I'll decide later exactly how and let you know. But I'll count it somehow if you take it. It may be, what I may do is replace a low quiz grade with it if you do better than your lowest quiz grade. So I kind of like that idea. All right, 3.4. Any questions? Did you guys get to it? Okay, 3.4 was about the counting techniques, permutations and combinations and factorials. So make sure that you go over that or watch the recording from last time. We went over that quite a bit. Just as a reminder, permutations is how many ways you can make, you can take n things total and make groups of r things if order matters. So permutations, order matters. Combinations, order does not matter. So that's what you need to know from that. All right. I'm going to erase this now. We may do this proctorial practice. I may have you go in and try that during the break if you want to, so that if you run into any problems, you can let me know. But you're going to access this. So what you're going to do, I'm going to go through the steps. Since you get unlimited attempts on this, I can at least go through the steps with you and get you started on it. We'll do that right before the break for those of you who'd like to try it. So I'm going to go through those steps one more time with you to make sure everybody knows how to access a test or quiz that's proctored by Proctorio. So we'll do that during the break. You don't have to actually finish it because you get unlimited attempts, okay? And I didn't put a timer on it either, except I think within Proctorio, I put a timer of like 4 hours on it so that if you forgot to go back and exit out, it'll eventually submit it for you. So I did do that. Okay, then in that case, we're going on to a different chapter. We're going to do one section from chapter 4. One section from chapter 4 is going to be on on test 2, and that's section 4.1. So we have been working on probability in chapter 3. The last section wasn't so much on probability. It was more about how to count things, but that was to get the total number of possibilities, which with probability is the bottom number. You know how you put the total number of things always goes on the bottom? That's kind of what we were working with in 3.4, was ways to get that total number for certain kinds of situations. But most of chapter 3 was about finding probability. Well, the reason why we are doing that is because probability is a big part of statistics, because they base things on how likely it is to happen. For example, your insurance rates, car insurance rates, are based on how likely certain things are to happen. Rates for teenage males are higher than rates for adult males. And that's because the probability of a teenage male being in a car accident that damages the car is more probable. The probability is higher. So probability is used with statistics all the time. And we're basically going to be talking about probability for the remainder of the semester for the most part. So, except for like the very end. So, when we talk about probability, one of the big things are probability distributions. And that's what's introduced to section 4.1. In 4.1, we're going to look at a particular type of probability distribution. Now, you've actually kind of done a probability distribution before. Remember when we did frequency distributions and you made a column and you had your class limits? Do you remember this? And then we had a tally column and a frequency column. And then we did midpoint. We did several things with our frequency distribution, and it was a table that kept track of the frequency of every class or or whatever your categories are here. But down here at the end, one of the last things we did was relative frequency. And that relative frequency column was really like the probability of that class occurring. So when we do probability distributions, we're going to list the different outcomes, and a probability distribution will have, the different things, the different values for X. And X is going to be called a random variable. And it's called a random variable. It's because it's going to represent a number, like the number of times something happens. I'll make up an example for you in just a second. And then in a probability distribution, it only has 2 columns. It has X, that's where you list all the possibilities for the random variable. For example, let's just do a simple thing, tossing a coin. Okay, and maybe we're going to toss a coin. Our experiment is tossing a coin 3 times. And a random variable always has to do with counting how many times a certain outcome occurs. So say you're tossing a coin 3 times, and you're going to count how many times it comes up heads, for example. Okay, so that it might not come up at all, or it might come up once or twice or 3 times. I'm going to make up a different example. This is one I like to use a lot. In basketball, every basketball player has a certain percentage of free throws that they make. For example, when Dirk Nowitzki was playing, when he was at his height, he was usually making over 90% of his free throws. Okay, so your experiment might be when Dirk Nowitzki takes 3 free throws, 3 shots from the 10-foot line. How many will he how many will he make? So the experiment is Dirk Nowitzki takes 3 shots, 3 free throws. How many does he make? Well, he might not make any of them, although the probability of that would be pretty low. So that number is going to be pretty small. He might make one of them, or he might make 2 of them, he might make 3 of them. Now, he either makes it or he doesn't. Okay, so this is called a binomial type situation, where there's 2 possible outcomes. He either makes the shot or he doesn't. And so maybe, and I'm just going to make up some numbers here, maybe we find out over time, based on all of his stats, that the probability that he makes all 3 of them is pretty high. Let's say the probability he makes all 3 of them is like 85%, and this might be 0.85. Okay, I just made that up completely. The probability that he makes exactly 2 of them. So we've already used 85% of the time he's going to make 3 of them. So when we say 2, it can't be, you can't have, these probabilities have to add up to 100%. They have to add up to 1. So I'm going to make up some numbers. Let's say the probability he doesn't make any of them is only 1%. And let's suppose the probability that he makes only 1 of the 3, let's make that 5%. Then what percent do I have left for him making exactly 2? So that's 6% plus 85%. Do you see what has to happen here? These probabilities have to add up to 1. So the sum of the probabilities has to equal 1. So tell me, if you were given this chart, what would that have to be? What percent is left for him making exactly 2? 9%, right, Christina? So 0.09. Now, I don't know if this is true, but I do know when he made 3 free throws, he often made all 3 of them. It might not have been as high as 85%. That would be really, really good. But, okay, we're just pretending. This is how we'd like Luca to shoot now. But that's another discussion. So when you have a probability distribution, do you see that our x, our random variable x here, represented how many of the 3 shots that Dirk makes? He either makes none of them, or 1 of them, or 2 of them, or 3 of them. And based on his history of shooting, we might know, oh, well, the probability based on his history that he makes all 3 of them, in the past, in all the years he played, 85% of the time he made all 3 of them. 9% of the time he only made 2 of them. 5% of the time he only made 1, and only 1% out of the time, 1 in 100 times, he didn't make any of the free throws. And that percentage may actually have been 0. I don't know. He rarely missed 3 free throws. He may never have done that. That's kind of an interesting question. But this is what a probability distribution is. It has 2 columns. 1 column to represent the values of the random variable, and then 1 column to represent the probability of that occurring. So now that we have this, we're going to talk about the characteristics of a probability distribution. You just saw one of them. These things have to add up to 1. The probabilities have to add up to 1. If they were in percent form, they have to add up to 100%. Another thing, all of these probabilities here have to be between 0 and 1, right? Because that's where probabilities have to be. All probabilities, probability of any event, has to be between 0 and 1. That's one of our probability rules. And remember that the probability, if the probability is 0, that means it's something that's impossible. And if the probability is 1, that's something that is certain. Those were the words I wanted you to learn. A probability of 0 means that thing is impossible. And a probability of 1, I need an equals there to include the 1. A probability of 1 means it's certain to happen. Now, this particular random variable that we did here, you know, where you count things, so we were counting how many free throws he makes. That's a particular kind of random variable. So we have two types of these random variables. One type is called discrete. And that's what this was here. This was a discrete random variable because we were counting it. Discrete means they're individual values. You can't have in-between values. So these are things you count. For example, and you can't have in between values. He can't make 1.5 out of the 3. That's impossible. Okay, he can't make 1.5. He can make none of them, 1 of them, 2 of them. Do you see? I can count how many he makes because he either makes it or he doesn't. But there are other kinds of random variables that aren't countable, but they are measured. And those, so we have discrete random variables, and then the other kind we have is continuous. Continuous random variables, these are things you measure. Let's put a few examples here. Things you measure might be height, speed or velocity, you know how fast you go, distance, that's something you measure, like how far you travel or how long a table is. Time is continuous. While you can sort of count time, there are in-between values. So while you may be counting off seconds, for example, you can have 1.5 seconds. So one way to determine if it's discrete or continuous, and that's going to be what some of your homework problems are about. One way to determine if it's discrete or continuous is that if you can have a half of something, that's going to be continuous. But if it's something you count, like how many dogs you have, you know you can't have half of a dog. So if you're counting how many dogs you have, then the number of dogs would be a discrete variable. Okay, but if you're thinking about how long is it going to take me to do this, how long does it take me in general to clean the house, for example, then that time is a continuous random variable. Another one that people don't think about as being continuous always is temperature. Temperature is continuous because you can have in between values. So these are a couple of the definitions, and you might see these definitions on the review Learning Catalytics quiz. You might also see them on the Proctorio practice. So what we're going to be doing in 4.1 is we're going to be looking at discrete probability distributions. And then basically the rest of the semester, we're going to be looking at continuous probability distributions. So let's erase this. this is what we're going to look at for in 4.1. It is discrete probability distributions like this one. Okay, I'm going to ask you some questions about this one. Let's pretend that this is correct for Dirk's probability distribution on how many free throws he makes out of 3 in a row. Okay, so I have some questions for you. What if I said, what's the probability that he makes fewer than 3? Now, if you did the skills review, then you saw things like this, like representing words with math. Fewer than 3. If I'm saying, what's the probability he makes fewer than 3, that would be the probability that x is less than 3. Can you get that answer from this probability distribution? I want you to think about that. Write down how you think you would do that while I check roll. So write in your notes right now, how do you think you would answer this question from this probability distribution? And I'll check roll. Be sure and raise your hand when I call your name. Ariana? Cecil? Diamond? Kayla? Kendra?
Anna's here.
Okay, thank you. Christina? Layla? Mia? Natalie? Stephanie Garza? Temperance? Yes, Mia, that's exactly right. Very good. Yes. So the way we would get the probability that x is less than 3 would be to add the probabilities. That means 0 or 1 or 2, because all of these outcomes would be less than 3. So yes, that's exactly what you would do, is you would add the outcomes that are the probabilities for the outcomes that are less than 3. So we would add the 0.01 plus 0.05 plus 0.09. So what did you get when you added those? I can't. 0.15. So 15%, the probability is 0.15 that he makes less than 3. Oh, and you guys can put your hands down. Thank you for roll. I always forget to tell you to do that. So the probability he makes less than 3 is 0.15. Notice that's everything but this one, isn't it? Less than 3 would be everything except making 3. So notice that making 3 and making less than 3, those are complementary events. Do you see how they add up to 1? 0.85 plus 0.15? Those are actually complementary events. Since it included everything except this one, I could also have done 1 minus 0.85, and that would have been another way to get this. Okay, I have another question for you. What is, let's erase this so we can answer questions. So we're still using this probability distribution. What is the probability he makes at least 1? First of all, what would the mathematical statement look like? The probability he makes at least one. Does anybody know how you would represent it, like with less than, greater than? What would at least one, at least would become what? I want you to think about what at least means. And what symbol should I use right there next to the X?
Less than or equal to sign?
Close. We do want an equal to, but okay, think of at least. Okay, so I'm going to put this in if I say I'm at least 30, is that true? You think that's a true statement? Of course I am. Okay, I'm at least 30. So what does that mean? So what does at least mean? And if you put it in terms of age, sometimes that helps.
Do you use the equal to or greater than sign?
There you go. Yeah. So it should be at least. Now I know why you're wanting to use less than, because you see least. So you need to think of the phrase. When you see at least, think of what does that mean? Like if I did an age, if I said I'm at least 30, does that mean I'm less than or equal to 30, or does it mean I'm greater than or equal to 30? It means I'm greater than or equal to. In this case, the number is 1. So at least is greater than or equal to. And that's a translation. You can make yourself a little like word dictionary, word to algebra. And at least will always mean greater than or equal to. Okay, now that we figured out what the symbol should be, what should I do? How do I get this answer from my probability distribution? And there are 2 ways I can do it. See if you can think of the 2 ways I can find that probability. Can y'all see that? It looks glary to me. Does it look okay to you?
Yeah, it looks fine.
Okay, thank you. I see a lot of glare from the window. So what do you want to do to find the probability that he makes at least 1? Christina says add. I can add these. Okay, now you've combined the two different ones. That first one is right, though. One way is to add these 3. Greater than or equal to 1 would mean to add these 3. So one way is to do this. Yes, that's one way. Okay, so and then the other way, okay, so let's stop there, all right? One way is to add these 3 here, and what do those add up to? That adds up to 0.99. So that means 99% probability that he's going to make at least one of the 3. Okay, now, Christina, you have the other method. There is another way I could have done this. I can subtract from 1, but what would I subtract from 1 to get this answer? When you subtract from 1, you're doing the complement. So if I want this right here, then this would be the complement. This would be like E complement or E prime. That 1 outcome would be the complement of this. So another way I could do this is I could say that probability is 1 minus, and I would subtract that 1. So those are 2 different ways I can do that problem. Let me read gotcha, right. Okay. Ariana, do you have a question? Mia, do you have a question? I see your hands up. That's why I'm asking. Okay. So hopefully you can see how when we have a probability distribution like this, we can answer different questions about it. So these probabilities that are listed in the probability distribution, And remember, this is a discrete probability distribution. So this is probability that he makes none of them. This is the probability he makes exactly one. This is the probability he makes exactly two. And this is the probability he makes exactly three. That's how a discrete probability distribution works. Okay? And it's kind of like, those probabilities are kind of like the relative frequency that we had before. So the way we would get that number, the way we would get these percents, is we would look over like Dirk's whole career and count how many times he took 3 free throws in a game and missed all of them, and put that over the total number of times he did that, took 3 free throws. That's really hard to say. And that would give us that probability for 0. Then we would count how many times he made exactly one of them, not one or more, exactly one out of 3, no more, no less. And put that over the total, and that would give us that probability, and so forth. So that's how a probability distribution works. And we're going to do some examples after the break of this, but I'm going to show you one more thing you can do with the probability distribution. A discrete probability distribution. And I'm looking at the time. Okay. And one thing you can do is you might ask, okay, when he takes 3 free throws, on average, how many does he make? That would be called the mean of the discrete probability distribution. So we're going to talk about this for just a little bit before the break. And let me erase this here. And I'm leaving this up because we'll do it for this probability distribution. If you've printed it out, get out your formula sheet for test 2. I'm going to get mine out. And what we're going to look at for the rest of the time is the formulas for chapter 4, which are at the bottom of the formula sheet. Remember, for the test, you may use this formula sheet and you may write notes on the back of it to use on the test. So this is your sheet. The other things you may use, you may print off the sample space handouts that I put on there, the one with the cards and the dice. Okay, I recommend that you have those out and handy when you're taking the test. Okay, so what I want you to look at right now is formula number 5 on the formula sheet. I'm going to write it up here in case you haven't printed it out yet. But formula number 5 looks like this. And it is the formula for the mean of a discrete random variable or discrete probability distribution. Let's change this just so it'll be worded the same. Discrete random variable. And this is formula number 5, and it looks like this. They're still calling it mu for the mean. Remember, mu is our symbol for mean. And it's the sum of the x's times the p of x's. So I'm going to show you how to do that for this problem. Now, finding the mean, remember, mean means average. So the question here would be, on average, when Dirk takes 3 shots from the 10-foot line, on average, how many of those does he make? We can do that because we have this probability distribution. So we're going to find the mean, the average number of shots he makes out of 3. We'll limit this to in an actual game. So this says we're going to add. Remember, this symbol means to add. And what we're going to add are these products. So for every value of x, we're going to multiply by its probability. So the first one is 0. Our first outcome is 0 times its probability plus. Our second outcome was 1. He makes 1 shot times its probability plus. And I'm sorry, I've run out of room, so I'm going to just put it down here. The next one is 2 times its probability plus 3 times its probability. I'm going to stop here. Does everybody understand where I got these numbers and how I used this formula to find the mean? This is how we're going to find, on average, how many shots he makes out of 3. Okay. So let's do this. So that means our mean is 0 times this is 0 plus 1 times that is 0.05 plus 2 times 0.09 is 0.18 plus, and I need to do that one in my calculator, 3 times 0.85 is 2.55. Notice I'm showing, I would type this if I was having to show my work on a test. I would type this stuff, not draw it. That draw tool in show work in my stat lab is really messy. Some of you did pretty good drawing with your mouse, but I want you to start using the type tool instead. Okay? Practice doing that in the homework. So I'm going to add all these numbers. So I have the 2.55, it's already in my calculator, so I'm going to work backwards, plus 0.18, plus 0.05. I get 2.78. Kendra, do you have a question?
So, want us to use the typing tool instead of the mouse, correct?
Yes. When you show work in my stat lab.
So not showing work, okay.
Now, if you were doing this problem, I'll tell you what to round to. But if you weren't given a rounding rule, then you would follow this rounding rule, which is what we were doing before. We're going to round one place past the data. Well, what's the data? The data was a bunch of zeros, ones, twos, and threes, whole numbers. So one place past the whole number is the 10th place. So more than likely, it's going to ask you to round this to one place. So this, I'm going to use a squiggly equals because I'm rounding. That means approximately. And if I round that to the 10th place, that would be 2.8. So on average, now I realize you can't make 2.8 baskets. That's impossible. But what we're saying is on average, when Dirk, remember I made these numbers up, so don't think they're real. On average, based on this, when this player takes 3 shots from the line, on average, we expect him to make 2.8 of them. So closer to 3 than 2. More likely to make 3 than to make 2, because that average is closer to 3. Now, I want to show you something. If you look at your formula sheet, I want you to look down at number 8. I want you to drop down to number 8. We'll work with we'll work on variance and standard deviation after the break. But look down at number 8, and you'll see something called expected value. And you'll notice that expected value, it says, is mu, which is this formula right here. So when you have a discrete random variable, that mean is also called the expected value. Or E of x. And on this one, it would be about 2.8. So it's like there's two different words for the same thing here. So the mean of a discrete random variable is the same thing as the expected value. In other words, it's what we expect to happen on average. You see how that's sort of the same thing? What we expect to happen on average. So I'm going to leave this up here during the break, and we're going to use this. We're going to need this expected value, this mean. We're going to need that to do the variance and the standard deviation. So I'm going to leave this up here. But if you want to at least start on the proctorial practice quiz just to make sure you've got it, you can do that. Or I can stay with you after class for a little bit while you practice that. But when you do the proctorial practice quiz, and I'm taking a break. This is all we're going to cover for now from 4.1. I want to talk about this. You get unlimited tries on this proctorial practice quiz. So the first thing you should do when you're using proctorial is make sure you are logged on to my stat lab. But don't open the quiz or test there. You're going to access it, get to it through Blackboard. So your second step, once you're logged in, and you can click on the class, but don't click on the test, okay? Because it's going to ask you for a password. You're not going to have a password, so don't ever do that, okay? So you're only going to log in and click on the class, but you're not going to click on the test or quiz. Then you're going to go to Blackboard under tests in Blackboard. Blackboard, remember that's your MyTCC. And you'll see the test or quiz there that you're going to access. It will look like a one-question test or quiz. That question will just be a link. When you click on the link, so you're going to go to tests and you're going to click on the test that you want to take. Or quiz. And then you're going to click on the link. When you click on that link, it's going to take you to my stat lab. Do not submit anything in Blackboard or Proctorio at this time. It's going to take you to my stat lab. It's going to put the password in for you. All right? And then you'll be able to take that. So this takes you to that's going to take you to my lab. You don't have to choose the test or quiz. It's going to take you straight to the quiz or test. Then you're going to take the quiz or test. And when you're done, you're going to submit. At that point, you're submitting it in my stat lab. Then the last thing you should do, if you want that camera to stop going, the last thing you do, go back to Blackboard. and submit there as well. Now, if you don't do that, I have it set so it'll submit for you after 4 hours. But during those 4 hours, I think the camera keeps running. All right, which means you get this long dead space. I don't know if it actually is showing you there, but if it was me, I think I would want to go back to Blackboard and submit there. Basically, you're submitting for Proctorio and letting it know, letting Proctorio. So you're letting my stat lab know I'm done with the test, and then you're going to back to Blackboard, letting Proctorio know, no, I'm done taking the test. You know, turn off the camera. So I want you all to please try. You know, you may not be ready to review for the test, and that's okay. But we want to make sure everybody's got this Proctorio thing down before we take test 2. All right. You're ready to do a lot of questions in 4.1. So you can do that. Or if you want to practice on the Proctorio quiz during the break, you can do that. If you need to do something else, that's fine. And either way, I will meet you back here at noon. I'm going to stop